Welcome to this comprehensive tutorial on implementing custom events in Unity 3D, specifically focusing on enemy defeated and on coin collected. These events are crucial for creating dynamic and interactive game experiences, allowing different game elements to communicate seamlessly. Events are fundamental in game development, enabling different parts of your game to communicate efficiently without direct dependencies. This means your player character, enemies, UI elements, and other systems can interact and react to changes in the game state in a decoupled manner, making your code cleaner and easier to manage. This modular approach leads to more maintainable and scalable code, crucial for complex projects. By reducing tight coupling between components, you can modify one part of your game without inadvertently breaking others, which is a significant advantage in large-scale development. We'll explore event-driven programming, a paradigm where the flow of the program is determined by events. Instead of a rigid, sequential execution, actions are triggered in response to specific occurrences, such as a player taking damage, an item being picked up, or a level being completed. Unity offers two primary types of events. Unity events, which are serializable and configurable directly in the inspector, and C# events, which are purely script-based and offer more programmatic control. Understanding both is key to flexible event handling in Unity. Let's begin by setting up our Unity project. First, create a new 3D project in Unity Hub. This will provide us with a fresh environment to start building our game and implementing our custom events from scratch. Once the project loads, we'll import necessary assets like enemy and coin models. You can use placeholder assets or custom ones. These assets will serve as the visual representations for the game objects that will interact with our event system. Good project organization is key. Create folders for scripts, models, prefabs, and materials to keep everything tidy. A well-structured project hierarchy makes it much easier to navigate, manage, and collaborate on your game development efforts. Now, let's create our enemy. Drag an enemy model into the scene, add a box collider component, and ensure it has a rigid body if physics interactions are needed. The collider will detect interactions, and the rigid body will allow for realistic physics-based movement or reactions. Create a new C# script named enemy and attach it to the enemy game object. This script will manage its behavior, including its health, movement patterns, and crucially, the logic for when it is defeated and how that event is communicated to other parts of the game. For basic enemy behavior, you might implement simple movement or a health system. For this tutorial, we'll focus on the event aspect, specifically how to trigger an event when the enemy's health reaches 0, signaling its defeat to other game systems. Next, create a coin game object. Drag a coin model into the scene, add a sphere collider, and mark it as a trigger. Marking it as a trigger means that instead of physical collision, it will simply detect when another collider enters its space, which is perfect for pickup items. Crucially, assign the coin a tag, such as coin, for easy identification in our scripts. Tags provide a quick and efficient way to categorize game objects and check their type during runtime, preventing the need for more complex component lookups. Now, let's implement the enemy defeated event. Open the enemy script in Visual Studio. This is where we will define the event itself and the conditions under which it will be invoked, allowing other game systems to react to an enemy's defeat. Declare a C# event using the event keyword and the action GameObject delegate type. This event will pass the defeated enemy's game object as an argument, providing context to any listeners about which specific enemy was defeated. Inside the enemy's script, implement the logic for when the enemy is defeated, for example, when its health reaches 0. This logic will typically involve reducing a health variable and then checking if it has fallen below a certain threshold. Before invoking the event, always check if it's not null to prevent errors. Then, invoke it, passing the enemy's game object. This null check is a critical best practice to ensure that there are active subscribers to the event before attempting to call it. Create a new empty game object in Unity called Game Manager and attach a new script named Game Manager to it. The Game Manager will serve as a central hub for managing game state, including listening for and reacting to various game events. The Game Manager will subscribe to the enemy defeated event. In its start method, find the enemy and subscribe to its event. This establishes the connection, so whenever an enemy is defeated, the game manager will be notified and can execute its own logic. Implement the Handle Enemy Defeated method in the game manager to perform actions like updating the score or spawning a new enemy. This method will be automatically called by the event system whenever an enemy is defeated, allowing for a clean separation of concerns. It's crucial to unsubscribe from events when the subscriber is destroyed to prevent memory leaks. Use the OnDisable method for this. Failing to unsubscribe can lead to references to destroyed objects, causing unexpected behavior and performance issues. Now, let's implement the OnCoinCollected event. Create a new C# script named Coin and attach it to your Coin game object. This script will define the behavior of the coin, including how it detects collection and how it signals that event. Open the Coin script in Visual Studio. We'll use the OnTriggerEnter 2D or OnTriggerEnter method to detect player collision. These methods are part of Unity's physics system and are specifically designed for trigger interactions, where objects pass through each other but still register a contact. Inside OnTriggerEnter, check if the colliding object is the player by comparing tags or using getComponent. This ensures that only the player character can collect the coin, preventing other game objects from inadvertently triggering the collection event. Declare a Unity event named OnCoinCollected. This allows us to configure callbacks directly in the Unity Inspector, providing a designer-friendly way to link actions to the coin collection event without writing additional code. When the player collides with the coin, invoke the OnCoinCollected Unity event. The null conditional operator is a concise way to check for null before invoking. After invocation, the coin game object should typically be destroyed to simulate its collection. Back in Unity, select the coin game object. In its inspector, you'll see the OnCoinCollected Unity event. This is where we will visually configure what happens when the coin is collected, linking it to other game elements or UI updates. Click the plus button to add a new callback. Drag a UI text element or a game manager into the object slot. This establishes the target object that will receive the event notification and execute a specific method in response. Then, select a method from the drop-down, such as a method on a game manager script that updates a coin counter UI. This direct connection in the inspector makes it incredibly easy to set up reactions to events without writing any additional code for the subscription. Let's review some helpful tips and best practices for working with events. Always use clear and descriptive names for your events and methods. This improves code readability and makes it easier for you and others to understand the purpose of each event and its handlers. Always check if an event is null before invoking it to prevent null reference exception errors. This simple check ensures that you only attempt to call an event if there are active listeners subscribed to it, preventing runtime crashes. Unsubscribe from events in OnDisable or OnDestroy to prevent memory leaks, especially with C# events. This is crucial for proper resource management, as lingering subscriptions can prevent objects from being garbage collected, leading to performance degradation over time. Leverage the Unity Inspector to configure Unity event callbacks. This allows for easy adjustments without modifying code, empowering designers and artists to hook up game logic without needing to delve into the scripting environment. Keep event logic simple and focused. Events should primarily signal that something has happened, not contain complex processing. The actual complex processing should occur within the event handler methods, maintaining a clear separation of responsibilities. Visual Studio is your primary tool for writing and editing C# scripts. Its integration with Unity is seamless, providing powerful features like IntelliSense, debugging, and code refactoring that significantly enhance the development workflow. Demonstrate debugging techniques by setting a breakpoint in Visual Studio and stepping through code when an event is invoked. This allows you to observe the program's execution flow, inspect variable values, and pinpoint the exact location of any issues. IntelliSense provides auto-completion and quick information on Unity API, significantly speeding up development. As you type, IntelliSense suggests relevant code snippets, method signatures, and documentation, reducing typing errors and improving efficiency. To enhance the visual appeal and clarity of your tutorials, incorporate relevant stock footage. High-quality visuals can help illustrate complex concepts, break up long stretches of code, and keep viewers engaged throughout the learning process. Captions are essential for accessibility, making your video understandable to a wider audience, including those with hearing impairments or non-native speakers. Providing accurate and well-timed captions ensures that your content is inclusive and reaches everyone. Finally, adding non-copyrighted background music can make your tutorial more engaging and pleasant to watch. Carefully chosen music can set the tone, maintain viewer interest, and enhance the overall production quality of your video without legal complications. We've covered creating on-enemy defeated and on-coin collected events, from C# event declaration to Unity event configuration. This journey has equipped you with the foundational knowledge to implement robust and flexible event systems in your Unity projects. You've learned how to set up your project, implement event logic in Visual Studio, and connect events in the Unity editor. This comprehensive approach ensures you understand both the code-based and inspector-based methods for event handling. Remember the best practices for clean, maintainable code and efficient event handling. Adhering to these guidelines will lead to more robust, scalable, and easier to debug game systems, saving you time and effort in the long run. Now, experiment with these concepts, expand upon them, and integrate events into your own Unity projects. The possibilities are endless, and mastering events will significantly enhance your ability to create dynamic and interactive game worlds. Thank you for watching, and happy game developing. We hope this tutorial has provided you with valuable insights and practical skills to elevate your Unity game development journey.